A single NDCG number can hide that your ranker is failing on exact queries, long-tail queries, or filters. Query sliced evaluation with ranx shows where the loss really lives. This is the setup you'll be able to run after this, which computes per segment scores and flags query types with significant metric drops. I'm Professor Pi, teaching search and IR with simple Python. Search teams often stare at a single aggregate metric and assume everything is fine. That single number can hide big gaps. For example, the overall NDCG metric, which measures how well relevant documents appear high in the list, can be healthy, while exact match queries or navigational queries are broken. Query sliced evaluation splits queries into meaningful groups so you can see those failures directly. The intuitive idea is simple. You group queries by a property, like query length or intent. Then you compute the same metric separately for each group. That reveals whether a change improves some groups and hurts others. This is a practical way to prioritize fixes and measure real user impact. We will build a tiny evaluation pipeline that computes per slice NDCG at cutoff 3 and highlights the slices with the largest drop. You will see a baseline run, a second run to compare, slices for short and navigational queries, and a final report that flags the worst segment. This keeps the code compact and the analysis focused. Now, we'll run a baseline evaluation. This snippet evaluates a minimal retrieval baseline using ranx and reports NDCG at rank 3. It first builds queries with queries, which stores relevance judgments per query, and constructs a run named run A that maps queries to scored documents. The evaluate function from ranx then computes the NDCG at 3 metric over all queries, ensuring consistent handling of ties and cutoffs. Storing raw dictionaries as queries_d and run AD keeps the data interpretable and reusable in later slicing steps. NDCG 3 emphasizes the top of the ranked list with logarithmic discounts, reflecting user attention. The printed overall score provides a quick health check before deeper slice analysis. Next, we'll compute a slice for short queries. This example slices the evaluation by query type using ranx to highlight segment-specific behavior. A small Q-types mapping tags each query. Then, short Q collects the identifiers for the short segment. Queries and run are rebuilt for only those queries with queries and run, preserving identical judgments and scores while restricting scope. The evaluate call computes NDCG at 3, specifically for the short segment, giving a targeted view that aggregate metrics often mask. Because we reuse QrelsD and run AD, the slice stays consistent with the original setup. The printed slice score shows how the system performs on short queries and sets a baseline for comparisons. Now we'll add a second system and compare on navigational queries. This snippet introduces a second system output and compares it to the baseline on a targeted slice using ranx. It defines run BD as an alternative run, then isolates navigational queries via navq. New QLs and run objects, QLsNav, run ANav, and run BNav, hold the same judgments but different rankings for just that slice. The evaluate function computes NDCG at 3 for each run, and delta captures the difference, SB minus SA, to quantify the change. A negative delta flags a regression on navigational queries that might be invisible in overall averages. The printed change focuses attention on where the new system degrades performance. Next, we'll test sensitivity to evaluation cutoff inside a slice. This snippet stress tests sensitivity to the evaluation cutoff within a query slice using ranx. It rebuilds, queries, and run for the short segment, then calls evaluate with two metrics, NDCG at 1 and NDCG at 3. The scores dictionary holds both results, and gap computes how much performance changes when only the first rank is considered versus the top 3. A larger negative gap often indicates that relevant documents are present but not ranked first, guiding re-ranking focus. Increasing the cutoff smooths sensitivity to exact top positions, while decreasing it amplifies head errors. The printed gap reveals whether short queries suffer at the very top rank. Now we'll assemble an automatic slice report to find the biggest drop. This example assembles a compact slice report with ranx to automatically find the biggest drop. It enumerates all query types, rebuilds crels and run objects per type, and uses evaluate to compute NDCG at 3 for both the baseline and the new system. Differences are stored in deltas, mapping each slice to its change. The min call selects the slice with the most negative delta, which is often the best starting point for error analysis. Expanding metrics or adding more slices scales this pattern without extra ceremony. The printed result pinpoints the worst affected segment, directing your debugging to where it matters most. In a real pipeline, this tiny setup maps to daily smoke tests. You compute slice scores after each deployment and alert when a slice drops. That keeps engineering focus on user-facing failures instead of noisy global averages. Recap: query sliced evaluation splits queries by meaningful labels and computes the same ranking metric per group. Use it when you need targeted diagnostics or when changes may trade off performance between query types. One caveat is that small slices can be noisy, so interpret single-run drops cautiously. For your next step, tune the cutoff and compare NDCG at 1 and 3 to see whether re-ranking or first-pass retrieval needs work. If short practical IR helps, subscribe and watch the IR videos.